Okay, homework files, help files for chapter 6. We'll start with 44. So we have this skater. She has initially 5.4 meters per second velocity. She's going up the ramp. The ramp is 0.4 meters above the ground. The end of the ramp is 0.4 meters above the ground, and it's making a 48-degree angle with the horizontal. So overall, we need to figure out this height to which the skater is going to rise after she leaves the ramp. And so all the information we have is her initial velocity, the angle, and this height right here. We don't know her mass, which gives you, hopefully you understand that mass will cancel in the end. So what we're going to be doing right here, we're going to figure out the energies that she has. In the beginning, she just has kinetic energy because she's on the ground. We're going to say that I'm going to say that's my zero level. So this is my H0. So my gravitational energy right here is 0, potential gravitational, and so she just has kinetic. Now in the middle right here, she will have 2. She will have kinetic energy, certainly less than right here because part of it turned into kinetic energy gravitational because of this 0.4 meters above the ground. And then, so she will have a certain velocity which will be less than 5.4, and it's going to be at 48 degrees to the horizontal, which means that it will be a projectile motion. And by the time the skater gets over here, she will still have some kinetic energy, but that kinetic energy is going to be just in the horizontal direction. So it's not going to be whatever that velocity is squared over 2 times mass. It's going to be this part squared times mass over 2. Because this part right here, the chunk of energy, which was mass over 2 times velocity, this part of velocity squared will turn into additional potential energy with the height, the big height. So again, kinetic energy initial split into 2. Kinetic energy right here plus potential energy due to 0.4 meters above. Then this right here is going to turn into 2 energies. Part of it will remain as horizontal, and another part will go into this final. I'm not talking about this total, like not this whole thing. The vertical right here, the vertical kinetic energy will just turn into this part. Anyway, not enough doodling. Oops. So keeping that in mind, in order to figure out how high she goes, I need to know what velocity she has at the moment when she's leaving the ramp. So in order to do that, I'm going to use conservation of energy because we're disregarding air resistance, friction, and whatnot. And so my kinetic energy right here, initial, equals kinetic energy right here plus mgh, where h is 0.4. So then I'm going to rearrange this, drag this over here with a minus. Then I'm going to cancel mass and multiply everything times 2, get rid of these, and it's going to be 2gh. So then, therefore, my V2 is going to be square root of V initial squared minus GH1. So putting numbers in, I'm going to get 4.6 meters per second. So at this moment right here, she has 4.6 meters per second velocity. So then, in order to figure out how much energy, which part of kinetic energy, again, here's my 4.6, this part is going to be 3.41. So if I do mass times this velocity squared over 2, I will get this chunk of vertical kinetic energy, so to speak. And that vertical kinetic energy turned into this potential with this height. So kinetic energy vertical, potential energy, which I'm looking for, mgh. And even though I don't know my mass, I can cancel it. So mass goes, and I divide everything by g, so it's 3.4 over 19.6, which is 0.6 meters. So there you go.